Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to take a look at a couple of galaxies and particularly at the different types of galaxy. So we're going to push a little bit past midnight. We don't have to wait too long for one of the richest areas of the sky in terms of galaxies to become visible. This is a pretty good time of year to look for galaxies, partly because the glow of the Milky Way isn't going to be in the way. So of course during wintertime, the galaxy's core, the core of the Milky Way, is pretty much behind the sun. So of course that means we don't get to see as much of the Milky Way. But to look for other galaxies, we need to look outside of the Milky Way. And looking over here in this direction, this area of the sky is quite rich in galaxies. So we're here at just half past midnight. Jupiter is just past the south. It's after passing its opposition. Jupiter is still very close to opposition. It's still a great time to look for it. If you take a look over towards the southeast at just about half past midnight. This is the constellation of Leo. Looking at it from here in the city, the trapezoidal sort of body of Leo is pretty obvious. The sickle at the top is not so clear. So we're going to get rid of a little bit of the light pollution, just so we can see a little bit more. So this isn't a perfectly dark sky, but it would be considered a rural sky. And that gives us a better idea of the shape of Leo. And of course, after Leo is Virgo, which is sort of this mess of stars down here. Its shape isn't very obvious. And most of Virgo is down below Arcturus, like the bright star Spica. We're taking a look just after the tail of Leo and kind of ahead of the beginning of Virgo. This area of the sky is rich in galaxies, and you can already see a few of them. So these kind of fuzzy shapes that aren't quite stars, many of them would be visible as fuzzy shapes even through binoculars. To get a good view of them as galaxies, of course, we need to take an even closer look with a telescope. So you can see that there are many galaxies in this region of the sky, and there are many different kinds of galaxies. So to make it a little bit easier, we'll bring up our markers for deep sky objects, and that'll give you an even better idea of how many galaxies are in this area. We've got some globular clusters visible here as well. So we're going to zoom in and take a closer look. First off, at M49 here. So M49 is an elliptical galaxy. And if we take a look over here in the description, it's E2. So this is an elliptical galaxy that is a little bit squished. It's not completely spherical or close to spherical. It's a little bit more elliptical. It's a little bit more squished, but it's not flat enough to be a lenticular galaxy or a spiral galaxy. With galaxies, they're often classified according to their shape, and it gives us this little number letter code that we see up here. If we click around to a few other galaxies, you'll see some different types. So these different galaxies, the S stands for spiral. A spiral AB galaxy, this indicates that it's not really barred, it's more of a normal spiral galaxy. But it is a little bit of a mix. It's AB, not just A or B. Here we go, this is SB0, so this is the lost galaxy. And although we can't see it here, the letter code up here tells us SB, this is a spiral barred galaxy. When galaxies were being one of the first systems to divide up galaxies into different types was the Hubble system of classification, and it really divided galaxies into three types: the elliptical, almost round galaxies, the spiral galaxies, and the spiral barred galaxies. You can see there are a lot more letters and numbers here. This is a galaxy that may become a ring-shaped galaxy in the future. This RS here is an indicator that it may end up having a ring of material around its center. And we can almost see that the spiral arms don't start directly from the center. They extend out a little bit. And this is common. Barred spiral galaxies seem to be a little more common than normal, I say normal, spiral galaxies. Unbarred spiral galaxies are the exception. barred spiral galaxies seem to be more common. This is a barred spiral galaxy, so we can see that quite clear bar here in the middle, but we can also see that the arms almost form two separate rings, and we can see there with the R's that we're seeing, it is a spiral barred galaxy, but it has this sort of a ring. It's also being shown as an active galaxy. Active galaxies are usually galaxies where the black hole in the center is sucking in material, and that produces jets of material coming away from the galaxy. It's got an active nucleus. An active galactic nucleus is really just a black hole that's generating jets because it's sucking in material. Here is a normal spiral galaxy, SA, and I keep saying normal, but really the barred spiral galaxies are the norm. About 2/3 of spiral galaxies are barred spiral galaxies. Only about 1/3 are not. Here is the blow dryer galaxy, and you can see that it does mostly look like a spiral. There's not much evidence of barring here. It does have the SA and B with an S, not an RS, because it's definitely still a spiral. It's not showing much of a ring-shaped structure. This division of galaxies into elliptical galaxies, spiral galaxies, and spiral barred galaxies, that gives us sort of a three-way diagram. This galaxy, it's only got a 2 on it, but this galaxy is tilted quite extremely, so we're not getting to see much of whether or not it's barred or spiral. We're not really getting to see it face on, which is what we need to do in order to easily classify it. By looking at the behavior of a galaxy, you can sometimes figure out what shape it is, even if you can't see it fully. The three divisions into spiral, spiral barred, and elliptical, it produces a sort of a shape like a Y. In the center of the Y are lenticular galaxies. So we're going to have a look at a lenticular galaxy here. So this is ESO, E/SO, which means it's elliptical slash lenticular. I need to get rid of the ground here. Hopefully there is a picture of it. Of course, there isn't a picture for every galaxy, so it looks like that's a galaxy that doesn't have a picture, but we can still get an idea of roughly what shape it should be thanks to those letters and numbers. Luckily, we do have another example of a lenticular galaxy. Unfortunately, it also doesn't have an image. This galaxy, the spindle galaxy, is a lenticular galaxy. It is a flat galaxy that isn't a spiral. So a spiral galaxy has spiral arms. An elliptical galaxy is round. But a flat galaxy that doesn't have arms, that's a lenticular galaxy. It's shaped like a lens. As I mentioned, for very fast spinning stars in a previous video, they're often lens shaped as well. So here we can see another spiral armed galaxy. Even though the spirals are very, very tight here, and even though we are looking at the galaxy at a little bit of an angle, it's not exactly dead on, we can still see that it doesn't have that strong bar across the center. The Milky Way is a barred spiral galaxy. We have that bar in the center, and that is the most common kind of spiral galaxy. The tuning fork diagram does lay out the shapes of the galaxies quite well. On one end of the diagram, you've got very elliptical galaxies like this one here that are practically balls of stars. And as you move along the tuning fork, the ellipses get flatter and flatter until you come to lenticular galaxies. Here we go. One of the galaxies in Markarian's chain, M86, is a lenticular galaxy. It's kind of hard to tell that it's not just a ball of stars here, but it is a little bit more squished than a true elliptical galaxy. The split in the tuning fork, the split in this Y shape, is after this flat lenticular shape. Once the galaxy has arms, it's either going to be a barred spiral or an unbarred spiral. But the tuning fork diagram, it is a little bit, I won't say that it's misleading, it purely talks about the shape of the galaxies. But the shape of the galaxies doesn't have much to do with their evolution, or at least it isn't, there isn't a direct relationship in the evolution. So for example, this silver streak galaxy here, the spiral galaxies and the spiral barred galaxies, they don't necessarily become more or less barred, more or less spiral over time. And elliptical galaxies don't necessarily become more elliptical or more lenticular over time either. Rather, what happens is that these galaxies, spiral galaxies and barred spiral galaxies, are smaller and they often collide to form elliptical galaxies. So elliptical galaxies of various degrees of various degrees of eccentricity, different degrees of how elliptical they are, they form from collisions of smaller galaxies. Now, of course, these things take a very long time to occur. We know, or at least we can estimate, that spiral galaxies come together to form elliptical galaxies because elliptical galaxies are almost always larger, and because we've seen spiral galaxies colliding, or at least we've caught spiral galaxies in mid-collision. So we can see a few more spiral-armed galaxies there, and another galaxy that we're looking at really edge on, so it's tough to see exactly how much of a spiral it has. We're moving up into Leo here, away from Virgo, to see some of these other galaxies. This area of the sky, it's a rich area of the sky across a broad area of the sky. So here we've got a lenticular galaxy, and you can really see its kind of long lenticular oblate shape. And here we've got an E1, very elliptical, a very much round ball of stars. And down here, we'll take a closer look. It looks like a pretty irregular galaxy to me. It may be an irregular spiral with some trace of arms, but definitely not the clear, obvious shape of the more obvious spiral galaxies. So we're going to take a look here. Hopefully there is an image for this galaxy. As we've seen, there's not an image provided for all of the galaxies, but these are okay. Doesn't seem to be. We can kind of see the distorted shape of this galaxy here, the Meat-Hook Galaxy or the Cobra Galaxy. This is because of these two galaxies beginning to interact, beginning to change each other's shape. Now, hopefully, this will bring me, unfortunately, not to a galaxy with a picture. There is another galaxy, the Antenna Galaxy, and it usually is the Antenna Galaxy rather than the Super Antenna Galaxy. Here we go. This is an example of two spiral galaxies that are really mid-collision. They've completely lost their spiral shape, but they will eventually coalesce into a more elliptical shape. Or at least that's how it seems to be. We can't see into the future, and we can't observe these galaxies over the billions of years that it takes for them to change shape. We just haven't been around long enough. But based on everything we can observe, we can see these spiral galaxies and barred spiral galaxies becoming elliptical galaxies. At least that's what they seem to do. So I hope you get a chance to see some of these galaxies. It's a fantastic area of the sky to look in and a great time of year at which to do it. I hope you get to see some of these galaxies, and even if you don't, at least you've learned a little bit about them here. If you enjoyed this video, please do like it. If you like this kind of content, then please subscribe to this YouTube channel. And if you'd like to read some of this information, you can head to my website, queevinscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.